we have done the easy ones for the sigma, the summation notation. We've done an easy question for recurrence relation. Today's one is a bit more on steroids. So if you don't understand, right, please be patient because usually it's the last mile that will trip you. But I think for this like for these intermediate ones, I think still need to do. But today we'll see a lot more harder questions. But be patient with yourself. I just tell you first. Okay. By right should still be okay, but more often than not, you see these kind of questions the first time. Yeah, and then as a result, you see this kind of question the first time during the exam some more. Yeah, so that's why it trips a lot of students up. But I hope that after today, right, you get to do the A level. Let's say if something similar comes at A level, you get to do with a bit more confidence. Yeah, that's a goal, lah. Okay, to get used to what is A level's idea of testing, and to get you primed to the thinking of how to solve these kind of questions. Okay, but let's do the easy one first. Okay, very quick recap. Yesterday we had question 6, right? No, the Monday we had question 6, and in this particular question over here, I will write down a few things that we did. So we did a few methods. We have method 1. We consider patterns or observe patterns. Okay, consider patterns, observe patterns, check and see whether is it AP or GP, right? And then after that, we sum using AP-GP formula. Next, method 2, we also considered how to split the summation. And after splitting the summations, right, we have a few options to choose. We can either observe AP-GP, so we will make use of the same techniques as AP-GP, or we may need to consider some of these identity. Okay, we need to consider R from 1 to N of R. So this means that 1 plus 2 plus so on until N. So this is half N plus 1. So this one is either you know or too small. Okay, this one is you should be aware, but you can derive on your own. Where do you derive on your own? How do you derive from your own? It's actually from here. This one, Sn will be equals to N over 2 A plus L. Okay, first term is 1, L, last term is N. So that's why you get the N plus 1. Next, we can also consider these other two identities, but it will be given, let's say, if you are required. Okay, so this one will be 1 over 6n, 2n plus 1. Sorry, I think got a bit more. Okay, then the r cubed one will be 1 over 4n square n plus 1 square. Okay, there's another one, but but this one usually will be given. So this one, don't worry about memorizing. This one usually will be given to you. Okay, back in my time, I memorized, but now very nice already. Okay, they will give you, don't worry. Okay, so this is in general, how do we consider to evaluate the following sums? Okay, now there would be another kind of questions, right, that or not say another kind of question, but there would be these kinds of questions where, because if we want to use the identities given to us, we need to make sure that the limits must match from r equals to 1 to n, right? So because of that, right, we need to more often than not do transformation on the limits. Okay, so we need to transform the summation. Okay, so idea is you need to change limit, change expression. Sorry, my handwriting, but like anyhow, but yeah, can. So these are the ideas that we will normally see in summation. Then the last kind of question would be inequality, where we will, that one we play cheat. Inequality is a place where we can cheat. Okay, but we have to cheat with a bit of thinking. Okay, so this is the idea that we have for summation and series, okay, the sigma notation. Okay, yeah, I give you some time to mull over this first, then we move on to 7. Okay, what's the sum of GP? A1 minus R power n over 1 minus R, or the other way around. Yeah, correct. Sum to infinity will be 1 over, sorry, A over 1 minus R. Okay, yeah. It's also to see whether, no, as in, what's the criteria for a GP to have a sum to infinity? That is the overall result, but how can you tell from one glance if the modulus of R less than 1? Yeah, correct. No, as in, if you have a limit over here, that means it's converging. That the series converges. Yeah. So there's many objects in mathematics, right? So previously we talked about the sequence converging. If we want to look at this, right, we say the series converges because we're adding things up. We're doing a summation. Yeah. So there's different things. So for example, Mr. Cool converges. Darius converges to the fruit plus. Yeah. Likewise, there is such thing as a sequence converging. So that one we use the algebra technique in question 5. Because the sequence term by term converge. This one over here, if we want to look at the convergence for this particular object over here, this is a series. So the summation will reach a finite value. Ah, ah. Okay, so yeah. Next one, question 7. Okay, so we'll look at question 7 to look at the change of limits. Okay, so question 7, right? Some of you do by brute force lah. You expand and then you split. Okay, can, but the problem is you're not using what is given. Okay, so because this is given, right, you are actually kind of expected to use this to do, to apply this into the summation. Okay, so I think in A level, right, usually they will give you the information that you need. Okay, it's not like EMATS where they'll give you extra the PRWC question where they will give you the extra information and then you just need to pick out the necessary ones. But for A level, they will give you necessary ones. Then you more often than not need to use. Okay, so let's see how do we use all these up. Okay, let's look at part 1. We want to sum from R equals to 10 to 2n of R times 3 plus R. Okay, so first let's observe this summation over here and this thing over here, they match, right? Right? These two components, they match, right? So we don't need to do any transformation. We just need to make sure that the limits, okay, because the limits start from 1, so we need to make sure that this limit also we have to change it to 1. But we can change it using our Sn. So this is actually S 10 to 2n, correct? So if we want to express it out from 1 to 10 and 1 to 2n, how? This will be S of 2n minus S of 9, correct? Cannot? Yeah, minus 9. Okay, so what do we have here? We have, okay, so R from 1 to 2n, okay, you are summing from 1 to 2n of this identity plus sum from 1 to 9 of this thing over here. Can? So then we just apply this straight away. A minus, sorry. Sorry, thank you. Okay, minus. Okay, so this is just applying the formula directly. So we have 1 over 3 times 2n. Okay, and then we have 3 plus 2n. Eh, wrong. 2n plus 1. 5 plus 2n. Okay, so mainly from here. From this one over here, come here. Okay, and also it's just applying this for 2n. Then we still need to apply the one for 9. So minus 1 over 3 times 9. Okay, then 9 plus 1, 5 plus something. Oh yeah. So this will be 9 and 9. Okay, so okay, so over here we will have 2n over 3, 2n plus 1, 2n plus 5 minus 420. Okay, can ah? Can ah? So far so good ah? Okay, so this is part 1. Now part 2 is the troublesome one now. Okay, let's so select. Can I do this? This and this, right? Cannot. Okay. Okay, let's look at part 2. Part 2 over here, we have summation from 1 to n. So this is nice. But we have r plus 1, r plus 4. Okay, now so some of us, right, as much as possible, we need to try to find back our r and 3 plus r if as possible. Okay, as much as possible, we do that. So some of you, or from what I see, some of us, we split this up, expand to r squared plus 5r plus 4, then take out r and 3 plus r over here, and then we have something left behind, and then you calculate more on your own. Something like that. But technically, we don't need, because you just need to observe the structure. So usually, right, when we are given this expression over here, right, we need to try to match it as much as possible. So I want you to observe the parallel between this r plus 1 and r. Correct, correct. And then let's look at r plus 4 and 3 minus r. Sorry, the other one. Yes. Okay. Can So can you observe the parallel? Technically, it's shifted by 1, right? Correct? Shifted by a plus 1, right? So technically, what we are doing, we are replacing r with, or actually, sorry, we need to transform this all the way back here. So we need to replace this r with something to get back our r. So means r will be replaced by r minus 1. Okay. So we will replace, one more time, we need to transform this back to this original form. Okay, we need to transform this back to original form. And because of that, right, we need to replace r here with r minus 1. Yes, then we check the limits, okay? So when r minus 1 equals to 1, r equals to 2. And then when r minus 1 equals to n, r will be equals to n plus 1. Okay, so this is doing the limits. Then we change the expression together. So this will be equals to, okay, so here we start with r equals to 2 to r equals to n plus 1. Okay, so change the limit. And then we will do like this. Okay, replace r with r minus 1. Okay, something like that. And then at the end of the day, we will see r2 to n plus 1 of r plus 3, which is exactly the expression that we got from the beginning. Okay. Correct. Okay, so now the thing is, okay, this one over here, right? If you notice, this is from S2 to n plus 1, correct? So means this will be equals to sum of n plus 1 minus of the first one, minus of the first term, or minus of sum 1 lah, sum to the one first term, which is the first term law, technically speaking. Yeah. Okay, so what do we need to do? Okay, we will just need to do express it like this first. From r equals to 1 to n plus 1 of r plus 3 minus of this one don't need, minus of the first term. The first term over here is 1 and 1 plus 3. Okay, maybe I should use this color. Change color. Okay, maybe I. Okay, can see what's going on? Can we are summing from the second term to the particular term, right? So means that if you want to sum from one to the particular term, you have to minus off back the first term lah. Then it's just this what? This is the same what? Same as previously what? Just now it's just now it's 10 to 2n, right? Right? So you sum from 1 to 2n and 1 to 9, minus of 1 to 9, right? So that you get your 10 to 2n. Similarly, this is from 2 to n plus 1. So we will take, if we want to take from r to n plus 1, we need to minus off the 1, the t1. Okay? Can Not a difficult thing, can do. Okay, so this one over here. Okay. Yeah. Okay, so here, right, we need to apply the thing already. So we have a 1 over 3. Here I will put in n plus 1. Okay, then here is n plus 1 plus 3. Sorry, n plus 1 plus 1. Okay, then the next one would be n plus 1 plus 5. Okay, minus 4. So over here, I'll have 1 over 3. Okay, n plus 1, n plus 2, n plus 6, minus 4. Okay, something like that. So this is for part 2. Okay, so here to here, apply identity. Okay, nice. Where? Sorry, can we leave it at this one? But this is not a AP or GP. Yeah. Eh, yeah. So this one over here, right? Because we need to make use of the identity above, we need to apply that, and that one starts from 1. So because of that, right, we have to take S2 to n minus 1, right? So means that how do we get this? This is S of n plus 1 minus of S1, correct? 1 before the second term, right? So what's S1? The S1 is actually the first term. Yeah. So this over here, right, is sum from 1 to Sn plus 1, which is here. This one is the term 1, or sum for the first term. Yeah, just like that. Okay? Can so I'm writing this to, yeah. DC circuits. Yeah, correct. But you all got learn the junction law and the Kirchhoff law, not? Kirchhoff. No, it's not alternate. That one is direct current. Direct current. But maybe no, right? Okay. But the thing, A-level connection also not easy to understand because they are connected in, yeah, it's everywhere. It's like this one, right, suddenly got like that. Or like you got this one, there suddenly like that. Yeah. Okay. Okay. Yeah, yep. Yeah, no, as in like, yeah, I'm thinking like how to not offend him. Oh yeah, 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 yeah. Yes, 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 yes. Yes, 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 yes. You have to, yeah. Yeah, he live by values, so. Yep. Huh? Why not? Can what? Why cannot? It will what? No, it won't. The pressure is not high enough to be up. Yeah, yeah. Okay. Okay. For the what? Oh, today got popcorn. And I think some old school chips. Okay, so technically, you will need to mingle with the 2606. Ah, I tell you, I got okay 26. I got T. So 2606 is the class. Okay, is the PCMA class with the highest, no, not highest, lowest average color point. No, 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 the lowest average raw one. Yeah. No, no, actually, it's the smartest PCMA class. Smartest PCMA class is not the 4H2 class. Yeah. Yeah. So that's the first fun fact that I've overheard today. Oh, no, because got gossip ma, like, oh, okay, I give you top class O6 你要不要? Then like, oh, okay, okay, okay. No, no, as in the deployment lah, the deployment. Okay, so the next thing, I don't have fun fact anymore about O6, but there are more. I see there are more guys also lah, as usual lah with this. Yeah. Okay. Yes. No, it's not. But you are close. I think 09 or 11, either one. Huh? Oh, 08 also, 08 also, yes, 08 also. 08 also, correct. Yeah. So it's, but then there's also other people ma. So yeah. Yeah. Highest, I don't know. Highest maybe from art lah. Typically from art. Because art ma, cut off is a bit higher. Yeah. Okay. Then later you will need to interact with them lor. Just need to say hi. I see that you all write cards, right? So yeah lor. Yeah. At the field. Everyone at the field. So it's, I think some icebreaker with them. Class leader should know. I think Jeanette should know. Yeah, yeah. Zhongxian should know. Yeah, so it's like icebreaker kind of thing, just to get to know them. And then got college dance. Yeah. Yeah, so just let them dance. Let the J1s dance. Yeah, let the J1s dance. Yeah. You just hype them up, can already. Yeah. Raise them up, hype them up. Yeah. Yeah. But yeah. So you are dealing with the PCME class with the highest, the lowest cutoff. No, with the lowest L1 R5. Yes. I think it's PCME. Yeah. Yeah. Correct. PCM something. Correct. Not PCM. PCM something. Yeah. Okay. Let's come back over here. Okay. So part three. So I think part two and part three, right? Same. You try to find the parallel between the two components over here. Okay. Then you see what do you need to replace. So in this case, how do I make the R minus 1 to become R? if reverse or correct, is to replace r with r plus 1. Okay, so r plus 1 equals to 1, so r will be equals to 0, and r plus 1 equals to 2n, r will be equals to 2n minus 1. Okay, so that's the first one. Second one, we will need to do this. So we change the limit from 0 to 2n minus 1, adjust the limit, adjust the expression also. So we have r plus 1, minus 1, and plus 2. So we have, Jialat, I'm slow. Sorry? Okay, next. This one over here, it will be 0 to 2n plus 1, right? So this one, you have a little bit of extra. So this one over here, right, is to sum of 1 to 2n minus 1 plus the 0 term. Can you visualize that this is going on over here? Okay, you are summing from 1 to 2n minus 1, but you need to top up a 0 term. Okay? Okay, now when r equals to 0. So what is going on here? Just apply the formula 1/3 a okay 2n minus 1. Okay, so then you sub in your 2n minus 1 and 2n minus 1 over here. Okay, sub in this into the expression, then plus the 0th term. So when r equals to 0, sub the 0 into this expression. When r equals 0, so this will be 0. So nothing changed. Yeah. So this one, you can simplify this to 1/3, 2n minus 1, 2n, and 2n plus 4. If you want to factorize out, you can put a 4n over here over 3, 2n minus 1, n plus 2. Okay? So something like that for part 3. Hannah? Yeah, so technically speaking, your cutoff is not the lowest, but is one of the top lah. So yeah, lowest, not the lower ones. So you all need to like live up to your potential lah. You get what I mean? Yeah, yeah. But I've been understanding lah. So, and I'm not a slave driver, so that's why yeah. Like I don't like never do homework. Yeah, never do homework. Yeah. I never do homework, tie you to 4 horses and pull your limbs apart. Yeah, I'm not. Yeah. 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 Okay, can. So yeah. Okay. So that's okay. Let's look at 9. Okay, 9 is the one that we will need to play with the expression above, but the last one is the troublesome one. Okay, and it's more often than not worth our time. But I think because you are striving for a solid A, so let's explore the possibility of getting a solid A. Okay. Okay, all done? Can I move on to 9? Okay, 9. First part very easy. Given that this, okay, so typically speaking, this is an edited question. Because usually when you see partial fractions like this, typically the first step is to express as partial fractions, correct? Expressing in partial fraction, you use method of difference, find this final answer. Part 1. Okay, but because method of difference is out, so they just give you this straight away. Now, find S infinity, stating clearly the reason. Now, because we need to state the reason clearly, we need to write down the analysis one by one. So, okay, so now we are looking for S infinity, means we are looking from sum from 1 to infinity of these 4r minus 4 and so on, right? Right? Correct? Now, so what does this mean? Okay, what does this mean? Is we are taking the limit as n goes to infinity of this expression over here. 2 over 3 plus 4 over n plus 2 minus 8 over n plus 3. Right? Correct? Right? Because the summation is given by this formula over here, right? And this formula is expressed in terms of n lah. Okay? So means that when we look for infinity, when n goes to infinity, okay, as n goes to infinity, this one goes to infinity, then we need to take the limit of this sum over here. Okay, this result over here. Can? Now, because of that, let's analyze the limit now. So limits of 2/3 is still 2/3. Limits of this is 0. So I will plus 0 minus 0. Okay, so you more often than not must put a 0 there because they ask us to show and state the reason clearly. Okay, so this is really stating the reason clearly lah. Okay, so s infinity will be equals to 2 over 3, like that. Not necessary. So the shorter method is as n goes to infinity, right? 4 over n plus 2 goes to infinity, it goes to 0. 8 over n plus 3 goes to 0, then you sub the 0 in. Yeah. Yeah. Yeah, you can just put 2 over 3 if it's just a 1 mark thing, but they ask for explanation lah. So the easier way to write may be that also. Okay. All right, part 2. Okay, find that thing over there. So now let's go back over here. Sorry, now let's come back over here. Let's find the parallel between the components over here. We have a r plus 2 matched with r plus 1. Then we have a r plus 3 matched with r plus 2, right? Then we have, okay, let me give, okay, r plus 4 matched with r plus 3. And technically the one above, right, this 4r can match with 4r minus 4, right? So you replace r with r minus 1. Wonderful. Okay, so I think now you can see. Okay, so for part 2, okay, let me write down this thing first. R from 1 to n, 4r over r plus 2, r plus 3, r plus 4. Okay, so technique, replace r with r minus 1. So here r minus 1 equals to 1, r equals to 2. The second one, r minus 1 equals to n, r will be equals to n plus 1. And because of that, change the expression. So this one would be 2 over, sorry, haven't yet. Okay, change. This would be r from 2 to n plus 1 of 4 r minus 1. Okay, then we have r minus 1, r minus 1, and r minus 1 over here. Oh man. Okay, so this one plus 2, this one plus 3, this one plus 4. Where? Replace all these r with r minus 1. Both upper lower limit must change. Yeah, just now. Can I upper lower must change? Can I see the color? Okay, see the color. Okay, next, let's apply or let's simplify this first. Okay, next. What do we do next? Analyze what is this? What does this sum mean? This is sum from 2 to n plus 1. So like just now, this is sum of n plus 1 minus of the first term, right? Can sum of n plus 1 minus of the first term. So over here, what we will do, change this to r equals to 1 to n plus 1 of this. Okay, this, I lazy. Okay, minus the first term. Now, first term, when r equals to 1, sub this inside over here. So I will get something like 4 minus 4 over this, right? And then this thing would be equals to 0. Okay, can see. All right, so next, Okay, next one we can apply the identity already. So the identity is 2 over 3 plus 4 over n plus 2 minus 8 over n plus 3. The n over here, this is the n plus 1. So I sub n plus 1, n plus 1 over here. Okay, next. Okay, tidy up. So this will be 2 over 3 plus 4 over n plus 3 minus 8 over n plus 4. Okay, so mainly like that. Okay, this one nothing much to shout out. Okay, now let's look at the interesting last mile question. Okay, last mile meaning, right, you sprint for a while, right? This last 3 marks is the last mile for you to clinch and secure the A lah. Okay, so how do we do this? Okay, this one over here, this is an inequality. Okay, this is an inequality. So now what I want you to do, right, is that I want you to compare this with the previous information given. Okay, I pause for, okay, I quickly scroll up. Now I want you to stare at this, right, and compare with the information given over here. This is an inequality, so you try to match as best as possible with some changes. Okay, so do we match this with this one over here, or do we match this to the original one? Up to you. Yeah, technically up to you lah, but which one should we match better? The top, because r minus 1, we can find the r minus 1 here. We have a r plus 2 cube. Over here, we have a r plus 2 over here, right? Technically speaking, the structure is there. What do we need to compare and analyze? We just need to compare and analyze the denominator. Okay? So the way to do inequality with summation and series, right, or in general, okay, is that we want to see the structure of the form. So here we have a r minus 1, we have a r plus 2, 3 r plus 2s over here. Cube, right, is this times this times this, right? So r plus 2, r plus 2, r plus 2. Then you compare the r plus 2 and the r plus 2 over here, right? Then you just play the inequality with r plus 1 and r plus 3. Can you see how this works? Can? Okay, if you cannot see, I write it out more explicitly for you. Okay, so yeah, you refer to question, okay, because I cannot scroll up and down, but the approach is, okay, the approach is you check and compare this. Okay, r plus 2 cube versus r plus 1, r plus 2, r plus 3. R plus 2, okay, anyway, okay. Can, something like that. Can, Okay, so if you break it out, r plus 2, r plus 2, r plus 2, right? Then over here, you got r plus 1, r plus 2, r plus 3. What are we comparing? Technically, right, this is pretty much the same, correct? So we are comparing the wings, right? We are comparing the wings. Okay, so let's analyze the wings. So let's consider, okay, consider this. Consider for r greater than 1. Okay, r has to be greater than 1, okay? Because we start with r2, because this is r11, okay? For r greater than 11, wait, r greater than or equal to 11, okay, something like that. Okay, let's take a look at this. Over here, we have, let's expand this and see, let's expand this and see. This is r squared plus 4r plus r. Expanding this and see, right? This one will be r squared plus 4r plus 3. Sorry, 4r plus 4. Okay, so obviously, which one is greater, the left one or the right one? The left one is greater, right? So left one more than the right one, like that. Okay, then we massage it back to r plus 2, or more like r plus 2 square lah. Okay, massage it back so that we can get something like that, right? And we will multiply back another r plus 2. And because of this, we are building it back to this form. Okay, r plus 3, something like that. Okay, so this is the first thing to consider. Next, you look at the question, right? What are we doing? This component is at the denominator, correct? right? So when we flip the prata, we have to change the sign. Okay? Can not because of negative, just like for example, 2 is less than 3, right? Half and 1/3. Half is more than 1/3 lor. Just like that lor. Yeah. So if you are not too sure, yes, correct. Use common sense and easy numbers. Don't use multiple of 2 and don't use the multiple of the same number lah, but use prime numbers. Yeah, they will tend to work nice. Okay, so something like that. Can Next, let's try to. Okay, so now with this, right, let's build up. So we can take the sum from R from 11 to N of R minus 1 of this thing. Okay, so we are multiplying R minus 1 on both sides and we are summing them from 11 until N. 11 until N, same R minus 1 over R plus 1, R plus 2, R plus 3. Can something like that. And also because the one in the question, right, given it all the way on top has a 4R minus 4, right? So I'm going to balance the 4 and the 1 over 4 here. Okay? Can. So now we set up the inequality. We massage it back or form back the original expression given to us. So this is the original one that's given to us. And we use this to apply the summation or the results given to us. Okay, to get our 11 over 256. Okay, so let's aim to do that there. Okay, so okay, so I will come here. Okay, and let's do the math. Not yet. Cannot. Actually, we cannot throw 11 eh. This one is actually S11 to N, right? Correct? But the formula given above is S1, right? Correct? So this will be Sn minus S10. Can Okay, so we'll apply this like that. So 1 over 4 of this hideous thing now. Yes, evaluating the right side, correct. From 1 to N of this thing. Oh, later. I'll explain more later. Like 1, 2, 3. I lazy. Okay, minus this one from 1 to 10. Okay, of 4R minus 1. This one. Okay, something like that. Can Now let's apply this. So 1 over 4. Okay, then we have okay, first one, 2 over 3 plus 4 over, okay, sub in the N plus 2 minus 8 over sub in the N plus 3. Okay, minus, okay, 2 over 3 plus 4 over, okay, sub in the 10 plus 2, sub in the 10, plus 3. The housework is 12 p.m. Fight. Steal coin and imprison people. It's not a gladiator. No lah, cannot. This one will get the teachers fired. Okay, so then what we have over here, 2/3 and 2/3 will minus off nicely. These two numbers at the back, right, will give us a very nice 11 over 39. Okay, then we have our plus 4 over N plus 2 minus 8 over N plus 3. Okay, and also because we multiply the 1 over 4, so over here we have 11 over 156. Very nice. Okay, plus a lot of rubbish over here. Okay, wait. Okay, can all right. Now, so far, let me explain what is going on over here again. Now, what we did was we compare, find the inequality from the beginning, try to form back the original expression with the inequality, and using this original expression, right, we want to evaluate the expression in terms of n and get a number out, correct? So currently, what is going on is this is less than this, right? But this is equals to this. So you see the change in notation, that's why I use the equal sign. This expression is equal to this expression. Okay, but if you look at the chain, this thing is still less than whatever that's thing over here. Can so that's the chain. But I'm going to do one more trick. Okay, I'm going to do one more trick. Now, technically speaking, right? Okay, so since n must be greater than 11, 1 over n plus 2 and 1 over... Oh, I see. Okay, can. Sorry, I need to do one more. I see. Sorry, I need to do one more. 11 over 156 plus minus n minus 1 over n plus 2 and need to combine. Okay, later you see why. Okay. Okay, now because n is more than 11, this one over here, right? This term over here, n plus 3, would be a positive number, correct? Plus 2, right? This thing over here is a positive number. So because of that, technically speaking, right, this thing itself, correct, is already smaller than that. Yeah. Okay, so if you want, right, you can put, I will put here lah. Okay, so this thing over here, let me erase. Okay. Okay, can so this is already less than this, right? Correct? So it will be less than a bigger number lor. Definitely less than a bigger number because you're minusing away a positive number over here, right? So this one over here will be less than 11 over 56. Okay? Something like that. Can So technically speaking, right, this last mile 3-mark question, right? Is it worth to do and struggle for now? I would say no lah. Okay, so if you happen to do halfway and then you find the working is too long, right, just skip first. Press on to the next few questions. Get your marks from the standard inequality, graph, vector, probability, get all those marks first. Then you come back and visit all these nitty-gritty details. Can? Yeah, especially for inequality, because inequality is a bit hard to see. A bit harder to see. This one take me some time to do also. Technically speaking, you are seeing this kind of inequality for the first time also. Okay, so with more exposure, definitely we'll see more of this kind of question, but it's also not common, so that's why you don't see a lot. Okay, and then this one is usually reserved for the last mile question for the really A people. Okay, so if you can, you try to persevere halfway. If you cannot finish, it's okay. Don't blame yourself. Earn the marks and be more careful with the other questions like graph, modulus, all those other questions. Integration, yeah. Mm. Must increase also, correct? Yes, precisely. The number of terms will stay the same. You change the lower and upper limit, right? But the expression also need to change. Correct. No, you cannot change one by one. You have to change all together. It's like integration by substitution. You must change all one shot. Correct. Correct. The number of terms will always stay the same. This is a very good observation. Yeah. Nice observation. Okay. Yeah. I don't disagree with you. Okay, let's take a quick look at number 10. Okay, number 10. Wah, jialat. 10 needs 13. Okay, can. I think I try to rush number 10. Okay, can No, 10D can do. Can do. Okay, let's go to 10. All right. So 10 is back to okay, a summation. Okay, we have a sequence of numbers. So this is talking about a sequence of numbers. Okay, it has a sum where the sum is like that. Okay, given the Sn is this, find the expression for Un or Tn. So this one I don't think I need to repeat, but the formula would be the un or tn will be equals to sn minus 1, correct? Right? So this is the expression that we're going to get. So un will be equals to an squared plus bn minus of an minus 1 square plus b n minus 1. Okay, so this one I let you do the math. I won't go through. I let you do the math and I'll upload the answers later. You arrive at 2an minus a plus b. Okay, I let you do the math and then you will do that. Okay, now part 2. It is also given that the 10th term is 48. So that means our 20a minus a plus b, right, will be equals to 48. So 19a plus b is equals to 48. This is equation 1. Then the next one is what term? The 17th term is 90, right? So this means that we have a 34a minus a plus b is equals to 90. So 33a plus b is 90. Okay, so this is equation 2. Using GC if you're lazy, but this is not a difficult elimination. A equals to 3, B equals to -9. Okay, so I will leave it like that. Okay, now let's dive in attention to part B. Okay, part B is the one where students see right there, what happened? Okay, but in fact, it's actually not difficult. You just need to understand what's the question trying to do. So, right, to be honest, right, math is not so much of math. Math is English. Okay, your GP skills or inference skills. Okay, so what's the question trying to say? I don't know how to pronounce this guy, but the Lambert's ratio test states that a series of the form, okay, the series are the Sn of this form, okay, they give you the form, converges when this happen, diverges when this happen, inconclusive when this happen. Okay, so this is the test. The conclusion is converge, diverge, inconclusive. GP skills are, okay, using the test, explain why this thing converges for all real values of x and state the sum to infinity of this series in terms of x. So this one, right, in case your English is very bad, your GP very bad, fail, almost fail, or S, but this one can match with which expression in this question? The one on top, right? So this one actually match with the series, correct? So technically speaking, right, if you notice the structure, you can actually see that you can consider, or you can actually see that AR would be equals to x power r over r factorial, right? If you notice the structure. Okay, even though you are blind, or not say blind, blind cannot see. Wait, sorry, and also a bit disability thing. Okay, but even though you cannot read words, right, but you can see the structure, same, right? Got sigma, right? Put the sigma together, correct? Compare the sigmas. Okay, then you Riesler together. Okay, then afterwards, so consider this as x power r over r factorial. Now, what do you want to do? What is the test? The test results is converge, diverge, inconclusive, right? But what's the test? The test is limit of this thing, a of n plus 1 divided by a of n, correct? A sub n plus 1 divided by a sub n, right? So technically speaking, we need to find what is a n plus 1 and a n. We need to consider that thing lah, okay? So means that we need to perform this test lah. This is the test. And then this is the results. The results, like that. Okay? So let's do the test. So limit of n tends to infinity. Okay, we have our, okay, a of n plus 1 over a of n. Okay, this one will need some math. Okay, so here, we will have our x power n plus 1 divided by n plus 1 factorial. This is x power n divided by n factorial. Now, I don't think you need a lot of, okay, I think by this rate, right, you can see that this simplifies to x over n plus 1. N, because this now is n lah. Now is n plus 1 and n, right? You can do r plus 1 over r. But your here need to r lah. You just change the r accordingly. Or r tend to infinity. Can then here must be R lah. Can. Okay, can do I need to elaborate how to get from here to here? Correct. Oh, no, it's physics. Okay, something like that. Can you see? Can you see this structure over here? Okay, can? So xn. Okay, can you see this and this cancels? Can you see that these and these cancel? Can all? Okay, so this one, right? Okay, we are considering the limit of what? N or x? Limit of what? N, correct? So x is like a constant in this limit. So technically speaking, we can take the x out. Yes, but then the limit as n goes to infinity of this fraction is equals to 0 because it becomes very small, correct? So this is just 0, and this tells us that the lim of n of this thing is less than, okay, this is equals to 0 and less than 1, correct? So because this is less than 1, they show, right? So this, okay, so what okay, so this from r to infinity of xr over r factorial converges. So copy the question of converges for all, yeah, I lazy lah. For all real x. Okay. Next, find what find the sum to infinity of this series. Okay, so technically speaking, right, if you consider this sum to infinity, right, it's actually expanding this out lah. So let's expand from r equals to 0, from 0, this one from 0. Okay, so when r is equal to 0, okay, we have x power 0 over 0 factorial. When r equals to 1, x power 1 over 1 factorial. When r equals to 2, x over 2 over 2 factorial. X over 3 over 3 factorial. X over 4 over 4 factorial, and so on and so forth, correct? So what is this? This one over here, 1 plus x squared over 2 factorial, x cubed over 3 factorial. What is this? Very familiar, right? Binomial series of what? Is Maclaurin of what? Bingo. So you refer to MF27. Which one does it match? E, right? So this is actually EX. Like that. Okay, so even though the question will seem very foreign, even though the question will seem foreign and strange, right, at the beginning, right, they will try to link it back to something that you know one. Okay, the previous question also try to link it back to the original form and try to massage from there. Yeah. Technically, you don't need to list it out also to be able to see. Okay, technically you don't need to list it out. So Zhongxian raised a very important point. Do I have to express everything out to see what's going on? It will be good to know lah. Because they asked us to state the answer, right? So technically all this working don't need one. You can just state EX. S infinity equals to EX. You get 1 mark. But how do you know that from one glance, right? It's actually from MF27. I quickly flash. Okay, if you see MF27, right? Okay, can you see this? This, and this. Okay, so to be honest, right, I've been using the sigma notation with you last time already lah, right? So generally, if this is the general term, right, it's sum from 0 to infinity of this general term over here. Okay, can so from one glance you can see that it's actually EX. Can now, so once again, this is a past year A level question. So the flavor of the A level is like that, where they will try to throw new things to you, try to throw new concepts to you, new formula for you to apply, but you just need to be brave to analyze the question and apply, because they will give you the information that you need to do it. Okay, for example, if they want you to do method of difference, they will give you the way to do method of difference. If they want you to do calculate the length of a curve, the integral square root one from one tutorial question, they will ask you to do that also. Likewise, for this question, they will give you the theorem to do the ratio test. This is actually uni year 1 or year 2 math lah. But they will just give you the result, ask you to apply. Okay, can Okay, so once again, how do you know what kind of topic is this? The clue is that you just need to see that's U1, U2, U3. So this means that we are looking at sequence. So your brain needs to compartmentalize this into sequences and series. So under sequences and series, we've done the series part, AP, GP, and the sigma notation. We are also doing the sequence part where we're doing recurrence relation and U1, U2, U3 kind of things. So the moment you see, right, AN plus 1 over AN, right, this falls under sequence. Okay? So you just put your brains to the different chapters. Cool? Okay, so we just call it a day here.